Okay, good morning. So we continue the lesson with complex numbers, but today I will not teach that much. I want to solve some examples related to what we have so far. But of course, I will try to give a little bit harder examples than what we actually need. Okay. So let me start with a simple example first. By the way, this example is a standard example. So example. So let z be 1 minus I, the complex number 1 minus I. Determine the real part of 1 over z plus the imaginary part of 1 over z. Yes? Okay, you can think a little bit about this so that I can change this. So what I'm supposed to do, if you want to calculate the real part and imaginary part of any complex number, you have to write it in this standard form. Standard form means that you have a number, a real number, plus another real number multiplied by I. Then whenever you have your number in this standard form or Cartesian form, then the real number A is called the real part of your complex number, and the number sitting next to I is called the imaginary part, yes? So if I want to answer this question, I have to calculate 1 over z first. So the first thing that I do is to calculate 1 over z. But of course, 1 over z is 1 over 1 minus I. It is not possible to read the real and imaginary parts of this form, yes? You have to write it in a standard form. But this is the division, yes? I told you, remember the trick. So if you want to write the division of two complex numbers in the standard form, you have to rescale the fraction by a complex number that makes the conjugate pattern with the denominator. So then it becomes 1 plus I multiplied by this. So the reason that this is 1 is because I want to keep the arithmetic the same as before. In the real arithmetic, we know that if I have a real number divided by a real number, if that number is not 0, this is 1. And if I multiply 1 by any real number, it should be the same number. And because I told you that I just add one rule to the game, I want to keep all the rules the same. That is valid calculation. And then of course 1 times that is very simple. And then I multiply. You can multiply, but it's better to use the conjugate rule. So it becomes the first one squared minus the second one squared. So then what happens? This becomes 1 plus I. Then wherever you see I squared, you have to replace it with minus 1. So this becomes 1 minus minus 1, which is 2. So then it becomes 1 plus I divided by 2. But if I want to write it in the standard form, I divide by 1 by 2 plus I by 2 so that I can write 1 over 2I. Yes? So this is 1 over z. So it is important to realize that these numbers probably was not that predictable from the beginning. You have to calculate and see what happens. And then, if I ask you what is the question mark, so the question mark is the real part of this number. I found the standard form of my number. This is the standard form of this number. And then this one is the real part plus this one is the imaginary part. Oh, sorry. Is the imaginary part. Imaginary part is not including I. And then these two numbers add to 1. So the answer to this problem is actually 1. Yes? Any questions? Okay, so this kind of calculus. So whenever you are supposed to calculate this. So let me test your understanding. What do you write in front of this? If I write z is a complex number. If I write the real of z plus imaginary of z times I. Instead of writing so much, what can I write? Simply write imagine z is a complex number. I take its real part and put it here. I take the imaginary part and put it here and multiply it by I and add them together. What happens?
The standard.
What then?
Is that the standard?
What can I write here? Of course, that's a standard form, but what can I write here? Pardon? Z itself, yes. Yes, I am taking the real part of z plus imaginary part of z multiplied by I. Definitely it becomes z itself, yes? Understandable or not? So if I ask you if this is z, if I ask you what is the name of this, you would say it is real of z. If I ask you what is the name of this, you would say imaginary of z. So real of z plus imaginary of z times I is definitely z itself. Yes. Okay, so let us go. So this I want you to understand, that's good to remember. If I give you a complex number like this, a plus bi, and I want you to factor I out, I want you to see that this can be written in this form. So this is good to remember. So sometimes you need to factor an I out. Is that understandable? If you don't believe, multiply it back. I times b is bi. Then this becomes minus a I squared. But I squared is negative 1, so it becomes positive 1. So sometimes you need to factor I out, so that's good to remember that you can do with using this trick. Okay. So I don't know, we already have done this before. So if I ask you, for example, to calculate, to put this in the simplest possible form, I to the power of minus 243. So if I ask you to put this number in its simplest possible form, so how can I do that? I have to make use of I squared, because that's the only piece of information that I have. So I will try to write this as I squared, but to the power of minus 121. So this becomes how much? It becomes 242. So I have one negative power left, so I have to multiply by a to the power of minus 1. Yes? But I squared is minus 1, so this becomes minus 1 to the power of minus 121. And then I to the power of minus 1 is 1 over I. But what is the answer here? Minus 121 is an odd number, and minus 1 raised to an odd number becomes negative 1. So the whole package here, this becomes negative 1, yes? If you're not happy with the negative power, that's the same rule, because minus 1 to the power of minus 121 can be written as 1 over minus 1 to the power of positive 121. But then minus 1 to the power of 121 is negative 1, and then you have 1 over 1, which gives you again minus 1. So you really don't need to demonstrate that. You can just simply write minus 1. Because minus 121 is also an odd number. This becomes minus 1 over I. But do you remember, I told you something about 1 over I. It's minus I last time. So this becomes positive I again. Why 1 over I? So what can I do? I can write it as 1 over I can multiply it by I and divide it by I. So then it becomes I times I squared is minus 1. So this becomes minus I. So remember, this is a nice thing to remember. 1 over I, of course it is equal to I minus 1, as usual, but there is something more in complex numbers that's also minus I. So 1 over I is minus I. So this I to the power of minus 243 is just nothing except this imaginary unit. So these kind of calculations, I think, is not hard for you to do. Okay, for example, let me give you another example. We want to simplify this expression as much as possible. 1 plus I to the power of 6 plus 1 minus I to the power of 6. Of course, all the rules that so here, if I want to assume that this is the same arithmetic as real numbers, there is one way to do it, and that's the binomial theorem that you studied in Math 5. And then, of course, you have to expand it. That is working, it's not wrong, but usually the goal is not doing this. If they have designed a question like this, might be the small powers of this will give rise to something that you can solve the higher powers easily. So if you have a higher power, of course we will learn, this is a very important part of this lesson, that we learn how to raise complex numbers to high powers. That is the main goal of this lesson, and might be this is the real reason why complex numbers are so handy to calculate things. I will give you examples as we progress in this chapter. But for the time being, I mean that in the future you will learn an easy, not easy, even the way that I want to do it here is easier than that made, but you will find a systematic way of how to raise complex numbers to high powers. Okay? But for the time being, you don't know that, so let us just try to find a way to solve it right now. So what I will do if I see this problem, I will try to see what happens if I raise it to power 2 instead of power 6. Okay? So I would do 1 plus I to power 2. And then this becomes 1, 2 times the first one times the second one, and the second one to power 2. And then you see that I squared is nothing except minus 1, and this minus 1 will cancel that one, and then I will get 2I. Okay, so that was a coincidence. You see, if I put another number here, then I will be in trouble, because if I put 2, for example, then this number becomes 4, this number becomes 4I, this number again becomes minus 1, but minus 1 plus 4 gives me 3 again. But it will be a binomial again, and raising it to power, I have to work with identities. But that was a coincidence here, so that 1 and I squared cancel, and instead of having 2 terms to some power, I have just 1 term to some power, so it is easier. Why? Because now, if I want to calculate the first part, I have to calculate this power 2, another one to power 3. The reason is that I want to calculate 1 plus I to power 6. Okay, and when I raise this one to power 3, I have to raise the other one to power 3 as well. But this one becomes exactly what I need. But this one is not hard to calculate. It becomes 8 I3. But you shouldn't leave it like I3, because whenever the power of I goes higher than 2, you have to reduce the power using I squared is equal to minus 1. So what I do, I would write 8 I squared I. But I squared is negative 1, so this becomes negative 8I. So we found that 1 plus I to the power of 6 is simply minus 8I. Do you remember? So I can call this number a pure imaginary number. Why? Because when I calculated that, what is the real part? The real part is 0. The imaginary part is minus 8. Yes? Okay. And I will do something similar for that one as well. So what can I do? So let us just do this one a little bit more quick. So that's the same thing to the power of 2. It becomes 1 minus 2I plus I squared. For the same reason I squared and 1 are cancelled, I will have this one. Then I raise it to power 3 to get power 6. When I raise it to power 3, it becomes minus 8I to the power of 3, minus 8I squared I, so it becomes 8I. Yes? And then the question mark is simply 0. Yes, because the question mark is equal to this one, which is minus 8I, plus that one, which is positive 8I, and this is 0. Okay, so that is interesting. You see, strange things happen, yes? So you know, if I have in real numbers, if x is a real number to power 6, plus another real number to power 6, and if it is equal to 0, what can you conclude about x and y? If x and y are real numbers, and I raise the first one to power 6 plus the second one to power 6, and it happens to be 0, there's only one conclusion, there's only one scenario going on. And what is that? Yes?
Both of them are 0.
They have to be 0. Why? The reason is that whatever x is, this number is non-negative because it is an even power in real numbers. Yes? This is not working in complex numbers. Yes? And here, this is also non-negative. I have two non-negative numbers on the one hand. On the other hand, I know the sum is supposed to be 0. This cannot happen unless each one of them is individually equal to 0. Yes? Is that understandable? Yes or no? But here you see a complete deviation from this rule. So here I have a complex number to the power of 6. Let me call it z to the power of 6. And I have another complex number, let me call it w to power 6. And I see the result is 0. But none of these are 0. One of them is 1 plus I, the other one is 1 minus I. So you have to get used to these kind of things. Sometimes you shouldn't carry all your feelings from real numbers when it comes to complex numbers. We want to keep arithmetic the same. But it doesn't necessarily mean that all our intuitions and whatever we have learned so far will remain the same. So that's a complete deviation from what we had. Okay, I will solve a problem for you and wait for you to see how you can solve the problem, okay? I just want to give you a little bit of challenge. So even though we haven't gone so far in this course, but you see the diversity of the problems that we can solve is actually quite broad, yes? This is the question that I want to ask you. Example, determine the smallest natural number n such that so we have this 1 plus I over 1 minus I to power n becomes 1. But that is also strange. Yes, do you feel that it should be strange? If you have your feeling from real numbers with you only. Why is that? Why this is strange? This cannot happen in real numbers. Yes? Why it cannot happen in real numbers? This is a number to power n is equal to 1. If I tell you n is a natural number and x is a real number, and I tell you that x to power n is equal to 1, what happens for x? If n is odd, there is only one answer, and that is 1. If n is even, then you have two answers, 1 and minus 1. But this number that you see is neither 1 nor minus 1, but I'm asking you to find n such that this to power that becomes 1. So you see that is also a deviation from what you had. If I ask you what is x here, so if I ask you the same question here, in the real numbers, I ask you, I don't know, this I cannot ask, but so if I ask you, can you give me the smallest number n that this happens if 2 is real, then I don't know, if 0 is allowed, you can say 0, yes? But if this number is 1 to the power of n, for all possible values of n, this is working, then you can choose the smallest one. But what I'm saying is that this problem becomes very easy if this number were actually a real number. But the problem becomes harder when this is a complex number. Okay, I'll give you a little bit of time to think how to try to find a way to solve the problem. Yes? Okay, any ideas what to do?
Is the answer true?
I don't know. We have to calculate, but well, how do you calculate things?
I use the conjugate.
Yeah, so for the number inside, let us put this in the, I think that's the good starting point. So what you realize is probably it's good to put this in the standard form. So 1 plus I over 1 minus I can be written as 1 plus I over 1 minus I. Then you have to multiply it by 1 plus I divided by 1 plus I. But then we realize that the numerator becomes 1 plus I squared, and the denominator becomes 1 squared minus I squared, yes? But then this is exactly what we did, so let me just do it quickly. And then this becomes 1 minus minus 1, so that this one and that one are cancelled, so it becomes just 2I divided by 2. Okay. So you see, this becomes I. So this number is nothing except I. So the problem was simple actually. So this means that I to power n is supposed to be 1. Okay? The natural numbers, of course I am not assuming n equal to 0 is acceptable because I to power 0 is also 1. But natural numbers, I mean this set. 1, 2, 3, etc. etc. Okay? Or if you want, you should say positive integer. Okay, and then I to the power of n is supposed to be 1. I have already excluded 0 because 0 was also correct. But 1 is not correct because I to power 1 is I. I is not equal to 1. Why is I not equal to 1? Why is I not equal to 1? Because two complex numbers are equal if and only if the real parts are the same and the imaginary parts are the same. Yes? If I ask you what is 1, 1 is 1 plus 0i. Its real part is 1, its imaginary part is 0. So what is I? I is 0 plus 1i. Its real part is 0, its imaginary part is 1. So this is the reason that y is not equal to I. That's not according to my definition of equality of two complex numbers. Okay, so n cannot be 1. Can it be 2? No, because I to the power of 2 becomes negative 1. So it does not working. Can it be 3? No, because I to the power of 3 we just learned. It's just minus I, which is not equal to 1. So the lowest value is 4. So the n, minimum of n is equal to 4. Yes? Is that understandable? Why I4 is correct? Because I4 is I to the power of 2 to the power of 2 minus 1 to the power of 2, which is 1. Okay. Even though I skipped the first page in the book, this was exactly Math 2C, but let me just give you one example. So solve this equation, x squared minus 2x plus 10 equals to 0. Solve on the set of complex numbers. Now, this is exactly the problem that you had in Math 2C. They gave you an equation, quadratic equation, and then you're supposed to solve and find its complex solutions if there are no real solutions. Okay, so if I want to solve this, I use ABC formula, yes? So what should I do? I would write x is equal to minus b plus or minus square root of b squared. You can also use PQ formula, it doesn't matter. Divided by 2a. So what is b? B is the middle number, minus b becomes positive 2 plus or minus b to the power of 2, and then minus 4a times c. And then divided by 2 times a. Then you see that this becomes 2 plus or minus the square root of. This becomes 4 minus 40, it's minus 36, and then divided by 2. Yes? If if I am supposed to find real numbers, that would be the end of the problem, and I would write there are no real solutions for this because under the square root sign I have a negative value. But now in the set of complex numbers, actually they are meaningful. Yes? How? Square root of minus 36 is equal to square root of 36 times minus 1. But the square root of the product is the square root of the first one multiplied by the square root of the second one. But this one is 6 and this one is just your I. That is just 6I. Yes? And then if I put it back there, so it becomes 2 plus or minus 6I divided by 2. And it is better to simplify, so it becomes 1 plus or minus 3I. So the answers are complex numbers, and that is, one of them is 1 plus 3I, and then the other one is 1 minus 3I. So I will not spend so much time on this one because that is simple. If you get some negative number under square root sign, you should get. If it turns out that this number is not a complete square, that's no problem. For example, assume that instead of having minus 36, I have minus 15. Yes? Then what you have to do, you have to write square root of 15 times I. And then you just keep it like this. That's it. So that's not a big problem. But let us try to solve more interesting equation problems, yes? So one problem that I want you to know about how to solve them is, let me write it here. Solve the following equation . Let me write equations, okay? The first example is very simple. So I can give you, I don't know, 1. I will tell that z plus 3I minus 5 is equal to 3I times z. We want to solve this equation. That is the simple example. This next one is also simple, but I want you to know the point. So what I have written is 2 imaginary parts of z minus z is equal to 5 times real part of z plus 1. So this is probably my goal of this example. So there are some equations in which you have only z involved, and that's not a big problem. So you need to, whatever you have learned for solving equations, you can also apply here. But sometimes you have a mixture of an unknown complex number and some imaginary or real parts there. Okay? So let us see how we can solve these two problems. So what do you think I can do for the first one? Okay, the first one, what is your opinion about the first one? So my equation is this. I have an unknown complex number z plus 3I minus 5 is equal to 3 times I times z. I'm trying to find z. So what should I do? Yes?
Move the unknowns to the left.
Exactly, like a first degree equation with real numbers, that's also a first degree equation because the power of the unknown is 1, and I do as before. So I move this to the other side, so it becomes z minus 3iz, And then I move the known parts to the other side, 5 minus 3i, yes? And then what happens, I factor a z out. And then I want to make z alone. Here I have to divide by this number then. So dz becomes 5 minus 3i divided by 1 minus 3i. That's okay if you stop here, but in principle you should be able to write this in the standard form. So in the standard form then you write 5 minus 3i, 1 minus 3i, and then you rescale it by 1 plus 3i, 1 plus 3i, yes? Now you know a little bit of these things, so let us try to do it in our head. So 5 times 1 is 5. Minus 3i times plus 3i is negative 9i squared, which becomes positive 9. Positive 9 and positive 5 is positive 14. Yes? And then you multiply 5 by that, it becomes 15i. Multiply this by that, it becomes minus 3i, so it becomes 12i. Yes? And then what happens for the denominator if you do it in your head? What's the answer? What's the answer? It's a conjugate pattern.
Minus 9.
10, yes? So remember, if you want, we can do it once for all, yes? A plus bi multiplied by a minus bi. We will see it, of course, later as in a systematic way. So this becomes the first one squared minus the second one squared. But then it becomes a squared plus, now minus b squared I squared, and then it becomes a squared plus b squared, yes? So whenever you multiply a number by its conjugate pattern, it becomes a squared plus b squared. And by the way, that's very interesting in its own. Why it's interesting? Why this relation is interesting? Do you remember, if I ask you to factorize a squared minus b squared, you can factor it out. What is the answer? A minus b, or a plus b, a minus b. Agree? But do you remember, if I ask you to factorize this, we couldn't do that. We couldn't write this as a product, but now we can. But we have to go for complex numbers. So that is why you couldn't factorize an expression like this before. But now you can factorize it, not in the realm of real numbers, but in the realm of complex numbers. Okay, so if I ask you to factorize this, if complex numbers are not allowed, you cannot factorize it anymore. But if complex numbers are allowed, what is the answer to this? It is just simply x minus 2i times x plus 2i. So I factored it out. Yes, I wrote it as a product. So anyway, this number multiplied by that number becomes the first one squared plus the second one squared, which, as you said, is 10. And then I will try to simplify that, but 14 over 10 is 7 over 5. Plus 12 over 10 is 6 over 5i. So that is the answer that I get for this. So there is nothing here actually, just normal calculations. The second one in nature is different, yes? We have to find a way to solve this. What is your opinion to how to solve number 2 here? Because this method will not work, you know. Z appears normally here, but under this imaginary part and under this real part. I cannot separate them so easily, yes. So what should I do here for finding Z? So these kinds of equations actually occur a lot in complex numbers, so please put a star on it so don't forget it for the exam. So if we want to solve that, we should say that, okay, I am looking for a complex number z, so let us decompose it as its real part and its imaginary part. So I would like this. I would say that let, for number 2, so this was number 1. For number 2, I would say let z that I am looking for, I know that z is a complex number, and any complex number can be written in this form, yes, where x and y are real numbers. This assumption is completely valid because z is supposed to be a complex number. Even if z is real, it is not wrong to say that z is equal to x plus iy, then of course y becomes 0. So then the question is that what is x and what is y? Instead of finding z directly, I write z as in this form, and then I find x and I find y. Then if I know them, I know z. But that is easy now, yes? Because if I ask you, so you see there are 3 ingredients here. One of them is z itself, I don't have any problems with. What is imaginary z? So if z is this one, what is imaginary of z? Is what? What is imaginary part? Imaginary part is y. Not y. No, don't say I. I repeat it. Imaginary part and real part are real numbers. When I ask about imaginary part, this you need to know, otherwise you get confused. Imaginary part is the one which is multiplied by I, excluding I itself. So that is the imaginary part. But what happens for the real part of z plus 1? I have to first calculate z plus 1. So what is z plus 1? Z is this one, and then plus 1. But if I want you to do this calculation, x is real, 1 is real. If I want to add, so it becomes x plus 1, and then plus iy. What do I need on the right-hand side is the real part of this number. So the real part of z plus 1 is equal to, what's your answer? What is the real part of z plus 1? X plus 1. And then what I need to do, I have to plug these expressions, this one and that one and that one, into my equation. So this becomes 2 times the imaginary part of z, which becomes 2 times y, minus z itself is equal to 5 times the real part of z plus 1, which is x plus 1. This is the equation that you're supposed to solve. Yes? But this equation is easy. Don't get confused. You might say that, okay, I have one equation, but I have 2 unknowns. But I told you equality of complex numbers gives you 2 equalities. The equality of real parts and equality of imaginary parts. So that is indeed 2 equations, not 1. So, but you have to simplify things a little bit. So on the left-hand side, if I can write it like this. I can write 2y minus x as the real part of the left-hand side minus y times I. On the right-hand side, I will have 5x plus 5. If you want to, you can imagine 0 times I, yes? And then the complex number on the left is supposed to be equal to the complex number on the right, so it gives rise to 2 equations. What is the first equation? The real part of this should match with the real part of that. And the imaginary part of this should match with the imaginary part of that. And that's finished, because from here, y is equal to 0, and then I plug it back here. So then it becomes minus x plus 5x is equal to, so minus 5x is equal to 5, so this means that x is minus 5 over 6. But do you remember, I was not looking for x or y, I was looking for z, but then z is done because it becomes minus 5 over 6 plus y is 0 times I. But of course, we can write it simply as minus 5 over 6. So, and then I want to repeat this. If you get a real number, that doesn't necessarily mean that you have done something wrong, because real numbers are already part of the complex numbers. Complex numbers are bigger, yes? So this type of equations, you need to know the trick. So you introduce the complex number and try to construct different parts of your equation and plug them back into your equation. And remember that equality of two complex numbers is not one piece of information, it's two pieces of information. Yes? Equality of real parts and equality of imaginary parts. Yes? Okay, there is a problem from the national exam, 1996 of course, and that time Math 4 was called Math E or something. But let me just write it here for you to see how you can solve the problem. So the national exam problem is determine real numbers A and B. So let me emphasize that they are real, such that Z equals to 1 minus I is a root or a solution of the equation Z squared plus AZ plus B equals to 0. So national exam 1996, yes? We want to determine real numbers A and B such that Z equals to, okay, I'm sorry, they have written, I want to keep this exactly like national exam, so they have mentioned 12. But let me just write 12 because that's national exam. A and B such that Z equals to 12 minus I is a root of this equation Z squared plus AZ plus B equals to 0. You can think a little bit until I'm cleaning this. Okay. What do you think about how to solve this problem? You want to find A and B so that when you solve that quadratic equation, one of the solutions turns out to be 12 minus I.
He's a magician.
So what should we do that? How should we do that? How do you think about the problem?
I don't think I don't have.
By the way, it is not that important how many problems I solve for you. The problem is that you need to learn how to think.
Yes.
And mathematics is probably a very good place to learn how to think. And if you learn that, it is actually very helpful even if you go to political sciences or whatever. The way that you think becomes very crucial. And I think it's a good idea to learn how to think. Okay, how do you think about this problem? By my experience, there are two ways that you can probably solve this problem. Usually students take the harder way to do it. Huh?
Maybe you can use ABC formula here.
Yeah, usually people do like that. That is not wrong. I haven't checked it myself, but I don't think there is something wrong with it. So you start solving this using ABC formula and find Z and try to match the formula for Z with this number. It probably works. But the point is that you have a square root sign involved there, and then you want to match it with that one. And so, by the way, we can think about it. And so you have to have the lost for doing this. And if it doesn't work, you need to change your way of doing it. So if you want to do it according to what Kevin said, and probably is a little bit natural to do, you would say minus b. But do you remember here a plays the role of b? Yeah. So it becomes minus a plus or minus square root of a squared. Sorry, b squared, which is a squared in this case, minus 4 times a times c, which is minus 4b, and then divided by 2. Okay, then what? In this way, even you don't see I. So, does it mean it is wrong or what? If you don't see I. Because the number, first of all, there are two numbers. Which one we have to choose to proceed, we have to think. This is one problem. The second problem is that I need to find I somewhere. But there is no I. But of course, you can find a way out of it. You would say that, okay, these numbers should be in a way that this turns out to be negative. Because if it is positive, the numbers are real, and this cannot be a complex number. So, but this is not equality. It's an inequality. So there are many, many options. You know, it doesn't restrict what you want to do. Okay. So apparently, in this way, you have to think. You have to write this down in the scratch paper. You see, it is probably not working. If you are so stubborn, and I really don't want you to be because most students try to do brute force calculations and everything to make it fixed. This is not good in mathematics. I'm not saying that many problems you have to do brute force calculations, but not in the beginning at least. Yes? Okay, so instead of forcing myself to solve the problem using this trick, let me just be patient and relax and then do another trick. So what's another one? Yes?
You plug that in and get the relation between.
Yeah, exactly. So that is the meaning of being a root. Yes? So that's good. And you will see this method will work better. So I would say that z equals to 12 minus I is a root. Yes? So then it implies that what? Implies that if I replace the z in the equation with this given number, it should work.
Yes.
But is this promising? You don't have to start calculating and then fail. You can think from the beginning. Is it hopeful? Is it promising to continue? Yes, because how many unknowns are left? 2. And this is a relation between complex numbers. And we learned that equality in complex numbers is not one piece of information. It provides 2, and then you have 2 unknowns. So it's promising. So we continue the algebra. So what happens, I square it, it becomes 144. 2 times the first one times the second one, minus 24i. The second one squared is plus I squared. And I multiply to a in. And then I have b equals to 0. What I have to do, I have to rewrite this in the standard form. So what is the standard form? This is real, minus 1. This is 144, so far 143. And then what are the other real parts? I have a 12a, that is a real part. And I have a b, that's also a real part. And then you see that what I have emphasized is not actually something extra. We have to know that a and b are real. Because if a and b are themselves complex numbers, I cannot say this is the real part. The real part should be really real. The imaginary part should also be real. Yes? So this extra condition is really needed. Yes? So 143 plus 12a plus b, and what I am missing, I have a minus 24i here, and I have a minus I here. So if I factor a minus and I out, it becomes a plus 24. And then I have this equal to 0. Even I have seen students sometimes move this to the other side and divide. That is not correct, because this is equality between 2 complex numbers. How? Yes? Now that is, I write it with bold, and then, yes? So 0 means 0 plus 0i. And then I have a complex number equals to 0 plus 0i. So this implies that the first part, the real parts should match, and the imaginary parts should also match. Yes? But this is easy. A is 24. A is minus 24. And then I put it here in this. Oh, sorry. This should be also 0. I put it here. So what happens? It becomes 143 minus 12 times that. 288. And then I have B equals to 0. So B is what? 145. And this is the answer, because in the problem they have asked you to determine real numbers A and B, so A is minus 24 and B is 145. So you see, if this is something that you need to really learn. This is the problem solving skill, and mathematics is probably the best arena for learning how to think.
Real number.
Any questions? Okay, let me give you also another question that I think I have taken it from Cambridge A-level problems. Okay, but so let me ask you: determine the imaginary parts of the roots. Or something similar. I haven't written it down that this is from Cambridge A-level. Determine the imaginary parts of the roots of the following equation. The equation is 2 times 1 plus I z squared, and then minus 4 times 2 minus I z, and then minus 5 minus 3I. Hopefully everything is right. This was not at the level of Math 2C, because in Math 2C, you could solve equations whose solutions are imaginary, but you didn't have equations whose coefficients are imaginary. But here, A is this number, B is this number, and the whole package here is C. That's a quadratic equation. So the algebra is more involved in this case. Okay, so let us solve this together, okay? So how do you look at the problem? So what is your starting point to solve this problem? Still, Z is missing, and I am supposed to find, so because determine the imaginary parts of the roots. First, I need to find the roots to be able to find the imaginary parts of the roots. Yes? So how should I do that? Yes? ABC formula. So the algebra is more involved here, but that's inevitable. We have to do it, yes? So if you don't mind, because this becomes complicated, let me calculate them separately. So this is A in this problem, and this is B in this problem, and this one is C. So if you don't mind, first let me just calculate delta. Delta is b squared minus 4ac. What appears below the square root is known as delta. The word for it is discriminant. Yes? Okay, so what is this one? This gives me minus 4, 2 minus I totally squared minus 4 times A times C. Yes? Okay, then what I have to do, this becomes 16. And then I raise it to power 2. The first one to power 2, 2 times the first one times the second one to power 2. But do you agree with me if I make it positive, and make this one positive as well? Yes? Because I can factor a minus sign out, and that minus sign that I am pulling out will I can get rid of this because it is better not to be worried about minus signs. Yes? So if you don't mind, so let me make it positive, and positive. And then what happens here, this is just simply 8. And then let us do this in our head. 1 times 5 is 5, keep it in mind. I times 3i is negative 3, yes? Because 3i squared is negative 3. 5 negative 3 is just 2, yes? And then 1 times 3i plus I times 5 is 8i, yes? Understandable? Okay, so then what happens? I squared is minus 1 plus 4 is 3, and then you multiply it by 16, it becomes 48. And then you multiply 16 here, it's minus 64i. And then you multiply here is 16, and then this becomes 64i. And then you see it is not that hard. This one and that one, whatever it is, it's gone, so it becomes 64. The delta is just simply 64. At this stage, you don't know how to react if the complex number, if the delta is also a complex number. The reason is that, for example, instead of 64, assume that you have this one. Then you have to work with this square root, but we don't know how to do it yet. We don't know how to take square root of complex numbers yet. Okay? So that's why I couldn't give you that kind of questions that this number remains complex when you calculate. So I fine-tuned it in a way so that it becomes 64. Okay, remember this was not a Cambridge A-level. I was inspired by a Cambridge A-level question. But Cambridge A-level question gives rise to this situation. Yes. Okay, so now what happens? I have everything. I go and solve the problem. So what can I do here? So z is equal to so let me just clean this one as well. So z is equal to, now everything is written, minus b. Minus b becomes positive 4 to minus I, yes? Plus or minus square root of delta, which is 64, divided by 2 times a, which is 4 times 1 plus I. And then you can simplify this because this becomes, I multiply it, it becomes 8 minus 8 plus or minus, again, 8 divided by 4, 1 plus I. So I will have 2 roots. One root, let me call it z number 1. This becomes, I take the positive sign, 8 plus 8 becomes 16 minus I divided by 4 times 1 plus I. This is one of the roots. The other root, I have to take the negative value. So minus 8, 8 are gone. So it becomes minus I divided by 4, 1 plus I. Yes? The roots, yes?
Isn't it 4 times 2 is 8, 4 times minus I, minus 4?
Yes, thank you very much. Thank you very much. It makes life simpler, yes? Because then it becomes 4i, thank you. I factor a 4 out, and I can get rid of this 4 as well, yes? Yeah, thank you. And then here it's also 4i, yes? Then it becomes minus I, 1 plus I, yes? Of course, the problem is not finished because they are asking about the imaginary parts of the roots, but then this is a standard problem. Yeah, because I'm a little bit lazy today, I will not do this, I will only do this simple one, okay? So if I want to find that, what should I do? As usual, I have to multiply by the conjugate, yes? So then what happens? Minus, so I multiply I in, it becomes I minus I squared, which is 1, and then I have plus I, and then this one becomes 1 plus 1. I have also a minus sign. It's minus over 2, minus 1 over 2i. So the imaginary part of z1 is minus a half. Oh, sorry, this is not z1, this is z2. You can do something similar here by multiplying by the conjugate of that, and then you will find the root. So that's also one type of problem that you might see. Yes? But you cannot solve all of these types if it turns out to be a real, at this moment you can, but if it turns out to be a complex number as delta, then you don't know how to do it yet. You will learn how to do it later. Any questions? Okay, so I will actually stop here. Thank you.